Hi everyone, my name is Benjamin Savakach. Once again, I'm going to present another practical, and this practical is basically based on pH indicators, and specifically I'm only going to look at the extraction of beetroot, the beetroot extract that we are going to use as a natural weak acid or base indicator. This is because this beetroot has a good pigment. It has a good pigment that acts or that reacts under different pH conditions, for example, basic or alkaline or acidic. So to come up with this experiment, we will need because this one was bought from the supermarket, and it is can be eaten as food. It can be used as medicine, or its dye, natural dye, can be used as a food color in food preparation of food. Then what else we shall need? We will need a basic, and in the base we have the sodium bicarbonate. We have vinegar. This is to give us the acidic solution. Then we have the containers that we're going to use for the experiment. I have a water bath here. So remember, in this experiment, we are going to see the effect of this natural indicator. We have to look at its fastness when it comes in contact with the cloth. How does it easily get off or stick? And then we are going to use a paper also. We are going to compare the paper and then this one. When it is washed, does it change the color? In case it comes in contact with the white paper or cotton fabric, we shall see. So from there, the water I have it here. Then we will need a knife. So the knife, I have this razor cutter. I'm going to use it for peeling and then extracting. We will need hot water. Instead, we were supposed to use a saucepan to boil, but in my location I don't have the heat source, so I decided to get hot water. You can see. So I'm going to use this one, and I'm going to peel off this, obtain the small pieces that I'm going to use to soak. Instead of boiling, I'm only going to soak it in hot water for about 10 minutes. Then I extract the juice that I'm going to use for the experiment. So stay on as we proceed. So I start with peeling. See, that's the original color of a beetroot. So members, this is not blood, this is the pigment I'm going to use. So I've extracted, and now I'm going to soak this beetroot has a strong purple red pigment that is almost similar to the color of that. So I'm soaking, and I'll wait for 10 minutes. Then we extract the juice. So neighbors, I'm back. I'm done with extracting my dye, the natural dye from the beetroot. So what else shall we need? We have to sieve, to extract separate the juice from the crystals, and I'll have something like this in one container. So we have this blood red pigment, and we are going to run the experiment by splitting this one into 3. The first one will remain in its original state. Like I said, we are splitting it into 3 different portions. One solution will be used for the acidic indicator. Another solution will be used for the basic indicator. Another solution will remain in its original state. So we have 3, and in our table, the results table, we shall have the condition. For example, you have 1 for the acidic on the right, 1 for the basic, then the original one in the middle. So I'll keep it down here. So this is on the right, I keep it's all in the same state, but I'm going to use the acid. So we want to see what happens when we add acid, this natural weak indicator. Then we are going to observe together. So we slowly add the acids in here. In this case, I'm using my weak acid, which is the acetic acid or vinegar. So slowly I will add the acid. So you add the acid as you stir slowly, and you note the observations. Slowly. So this process takes a long time. Now I have 2 solutions here. This is the original solution. This is the solution. I've added the acid. So this one is still at the neutral. It still owns the state. But when you look at this, there is a difference. This one is a little bit diluted and pinkish in color, meaning that slightly this red purple pigments changed to pink color, meaning that it shows that the acidity level the pH level has slightly dropped, hence forming an acidic solution. So, meaning that when you add acetic acid to these the pigments of the beetroot, the indicators it will show, the color will change, meaning that when acetic acid is added, it changes the color, though it's in a weak state. So from there, we are going to have the basic solution. This acidic solution will be covered after observations. And as now that I have this solution also now, I'll be adding this base slowly as I stir. I hope you are not seeing the changes. So it was reddish purple, but after adding the solution, it is changing to bloody purple color. I think you can see. So before it was already blood, it was purple red. Now it has turned completely to purple color, indicating that now the solution is a little bit now basic due to the effect of the salt solution or the sodium bicarbonate. This indicates that also natural pigments can be used as natural indicators. Thank you for listening and for watching. We'll see you in the next examinations. This one remained in its original color. This one changed into purple. This is red purple. You can see this one has changed to only purple because of the effect of the sodium bicarbonate. This one turned to pink because the acid solution that was added. So I think you can now tell the difference. This one is slightly acidic. This is basic because of the salts added, sodium bicarbonate, and this one is basic. It's in its original state. So, in simple terms, that is it. Beetroot pigments can be used as a weak natural pH indicators.